Hello, today we have this Putnam 1997 problem. By the way, I got a Discord server, so you can check the description for it. So what we have here is a group and a function, and we have to prove that for another function constructed by multiplication of a result of that function by a. This is supposed to be a homomorphism, well, at least for one of the a's in the group. And we have these two properties. If three elements after getting the product equal to the identity element, then the product of the values of the function for these elements is supposed to be a constant. So let's call it constant t. So thing is, we can instantly compute the t. We can take phi of e times phi of e times phi of e equals t, and well, that's it. Because e times e times e is equal to e. This is another problem. So we know t now. This is already useful. Let's continue investigating into the properties of the function phi. Let's look into phi times a times phi times a inverse times phi of e is equal to phi e cubed. Okay, we have this. Now we can rewrite this as phi of a times phi of inverse is equal to phi e squared. And now we can represent phi of a and phi of a inverse in a bunch of ways in terms of each other. This is just a bunch of useful properties that could be helpful later on. You can say that phi of a inverse is equal to phi of a times phi of e to the power of -2. We can say that phi of a is equal to phi of a inverse times phi e squared. We can say that phi of a inverse is phi of a inverse times phi of a squared. Okay, so we have a bunch of different properties that could theoretically be useful to us. I mean, I don't see reasons why it wouldn't. So let's go ahead and try to use them. Let's say that psi of xy, as we have said, is equal to a times phi of xy. So now let's transform that somehow. First of all, we can return to this equation over here and say that a times phi of xy. Now we're going to introduce a product phi of y inverse times phi of x inverse, and then we're gonna bring this back by taking the phi of x inverse and phi of y inverse. And we can go ahead and use the associative property to isolate this. And as we know, this is a constant equal to phi of e cubed. So we have a times phi of e cubed times phi of x inverse times phi of y inverse. So we can return to the table of various properties that we have derived, which are actually pretty useful. So under our book of properties, this is gonna be phi of x times phi of e to the power of -2 times phi of y times phi of e to the power of -2. This is really useful for a multitude of reasons. Oh, and also we can rewrite this as a inverse times a phi of A inverse equals to phi E squared. And from this we can derive that phi of A inverse is gonna be phi of A times phi of to the power of -2. Okay, wait, that doesn't change a thing. Okay, I'm having a brain stupid. Okay, I can see why I'm having a brain stupid. I thought it's supposed to be changed. I think that's because I messed up here. I wrote the property differently. It's not correct. Well, it's technically correct, but it's for the other form. If we were to multiply the right side by inverse of this, we're gonna get inverse here, just E here, and then we can multiply the left side by this, and we have phi of E to the power of -2 times phi of A. And that is basically some more drill here. Phi of A is going to be phi of A inverse times phi of E squared. And here, phi of A inverse is going to be phi of A inverse times phi of E squared. Now, this part here is really important. And ask me, why is this really important to me? This sort of difference thing. Well, you can see that this is not a particularly nice form to work with, but if we were to swap the sides we work with, it's going to be really convenient. Have A times phi of A cubed times, now we take this form instead. So we have phi of A to the power of -2 times x, not just x, phi of x, times phi of A to the power of -2 times phi of y. And the difference here is that we can clump one of these with this leading one in the beginning. So what we have is A times phi of E times phi of x times phi of A to the power of -2 times phi of y. And now what we have to do is just solve an equation. We say that this is supposed to be equal to A times phi of x times A times phi of y for psi to be a homomorphism. So what we can do is we can right away cancel this out. We can cancel phi of y on the right side. We have here is phi of E times phi of x times phi of A to the power of -2 gonna be equal to phi of x times A. So phi of x inverse times phi of E times phi of x times phi of E to the power of -2 is equal to A. Now we can apply one of the properties we have found over here. This is going to be phi A to the power of -2 times phi of inverse of x So, thing is, what we have here is basically we can apply this original property here. It's really handy formation. So this is just gonna be phi cubed, phi of E cubed, I mean. So phi of E to the power of -2 times phi of E cubed times phi of E to the power of -2 because A. In the end, A is equal to the inverse of phi of E. That's it. We can safely say that A exists. I even found the value of E in terms of a value of phi inverse. It really does exist now. We can safely say that because phi of E is supposed to exist because E belongs to G, then phi of E is supposed to belong to G, and since G is a group, there's supposed to be an inverse. So we have solved this. Thank you for watching. Bye.